In this video, we're going to talk about how to solve equations that have logs in them. So we have a few steps here to solve log equations, but sometimes we don't need to do every single one of them. I'm still going to go through all of them here just so we realize that we want to consider them. The first one is to combine into a single log. In this equation, I only see log written down once, so see how this is a step we don't have to worry about. This one isn't really useful for us in this problem. The second one is to isolate the logarithm. What that means to do is to only have log with a base and an argument on one side and then a number on the other side. So let's take a look what we have right now. Log, base is 5, our argument is in parentheses, that would be the x minus 1, and it equals 2. So it looks like steps 1 and 2 aren't something that we need to worry about in this problem. All right, we will always have to worry about step 3 though. That is going to be changing from log form into exponential form. So right now it's in log form. We're going to take the base from the log and it's going to become the base of our exponential form. The number is going to become our exponent and it's going to equal the argument. So let's do that with this example right here. 5 is our base. Logs equal the exponent, so 2 is the exponent, and that will equal the argument of x minus 1. Right, so this was using step 3. The next step and last step is to solve. Well, let's see, what are we solving for? Our variable is x. Right, that means we're trying to get x by itself. So I'm just going to jot that down. This is to get the variable by itself. And sometimes that is more complicated than in some more so in some situations than others. All right, so here's our x. We want to get that by itself. I also want to do some simplifying here. Since I know what 5 squared is, let's write down that that's 25. But I think we only have one thing that we need to do to get x by itself, and that's to add 1 to both sides. Right, to cancel out that minus 1. So we get x equals 26 is our final answer. Let's try another problem. So notice I've left the same steps here. I'm going to start all the way back at the beginning because we might have to do this. Combine into a single log. I only see log written down once, so this step is already taken care of. We don't need it to do any combining. Next is to isolate the logarithm. Remember how I said that was to get log, a base, and the argument all by itself on the left and a number on the right. That means that this minus 1 has to go. So we're going to add 1 to both sides to cancel that out. This one's different than the one we just did. Let me flip back and show you for a second. See how this minus 1 was in parentheses with the x? That told us that this was the entire argument. When we don't see that, right, this minus 1 is not in the argument with x. That's why we had to move it over here. The next thing we're going to do, since we just finished step 2, is to change from log form into exponential form. So we take our base, which was 2, the exponent, which is what a log equals, that's 4, and that will now equal the argument, which is x. Awesome, we did our changing, and solving means to get the exponent by, get the variable by itself. It's already by itself, we just need to do some simplifying. What's 2 to the 4th? That's 2 times 2 times 2 times 2. We get 16, and we are done. Okay, I think our next one we're going to have some more steps to do. Okay, this time we have 2 logs that we're working with, so we do have to do this first step of combining. So we're adding these logs. The rule says that we take the arguments here and we multiply them together. That makes up the new argument of 2x. We keep everything else in the log the same. It's log base 6. Everything else on the right stays the same as well. So we just did step 1. We combined into a single log. Next, isolate the logarithm. I don't think we have anything to do here. We have our base, our argument, and basically the exponent, right? Nothing to do on step 2. Step 3, we always do. We have to change from log to exponential form. So we start with the base. 6 is the base, 2 is the exponent, and that's going to equal 2x. So we changed forms. I'm going to do some simplifying. We get 36 equals 2x. And now it's time to solve. We want to get x all by itself. So to do that, we want to cancel out the multiplying with some division. So I'm going to divide both sides by 2. And I get that x equals 18. Okay. Next problem. Notice that we have a little bit more of a complicated problem here. We have 2 logs, so we're going to have to do some combining. We are adding these logs, which tell us to multiply the arguments, except we have an extra number out here in front. I can't put these logs together until this 2 is out of the way. And what we do is that we move it up here to be the exponent in the argument. So let's do that first. I'm going to write down that the first log stays the same, and the second log is now a log base 5 with no coefficient in front. We're going to get that to be 2 squared. Now that there are no coefficients in front, now we can put these logs together. 9x gets multiplied with 2 squared. Well, 2 squared is 4. I'm going to write times 4 in there. And let's do a little bit more simplifying. We know that 9x times 4 is really 36, so we get 36x for our argument. Okay, so let's see what we've done so far. We've combined into a single log. Have we isolated the logarithm? Yeah, we have a base, an argument, and the exponent. Nothing more to do with that. That means it's time to change forms. So we get 5 for our base, 2 for our exponent, and that will equal 36x. Next, we're going to solve for x. I'm just going to simplify before I get the x by itself. So this is now a 25 equals 36x. And just like the one we did, we're going to do some division here. So we'll divide both sides by 36 to cancel out the multiplying. And we get a fraction that does not simplify. So I'm going to leave my answer as that fraction. So we get x equals 25 over 36. All right, we got one more problem because I want to make sure that we work with ln. Right, ln just means the natural log. If you wanted to put a little e in for the base, that would be fine. It's still a log, just a base of e. And we're going with the same steps. Combine into a single log. I only see one of these ln's, right? There's no other ln here, so that step's taken care of. Next, we need to isolate the logarithm. That, I think we have a lot to do here. So let me just switch colors for a second. Look at the things that we don't want to be by the log right now. Isolating means we have a log with a base. This 6 in front, that's a problem, right? We have an argument, that's fine, but we also don't want this plus 14 there. We just want the log, the base, and the argument on the left side. So the 6 and the 14 have to go. We also have to make sure we take care of these in the right order. We're going backwards order of operations when we solve, so I'm going to cancel out the plus 14 first. Let's subtract 14 on both sides. So now I just have the 6 and the ln, and that equals negative 12. Okay, so we've gotten rid of the 14. Next, we have to get rid of this 6. It's being multiplied with the log. That means I have to divide the left and the right side by 6 to cancel it out. So now I just have the log on the left side, and the right side simplifies to a negative 2. All right, we've done our job isolating the logarithm. Now it's time to change. This is where you might want to put the e, like I mentioned before. Now we can see what the base is. So e is our base. Logs equal exponents, so -2 becomes the exponent, and then that equals the argument. So we changed forms. Next is to solve for x. I have to get x by itself. Over here, e to the -2, that's just a number. I really can't simplify that right now, so I'm going to go right to our solving. We want to subtract 6 on both sides. These aren't like terms, so I'm just going to write it as e to the -2 minus 6, and that equals 3x. And then I'm going to divide both sides by 3. Again, nothing here simplifies. That is a complicated, but it is an exact answer. Okay, this is an exact solution. If you were ever asked for an approximate solution, we would have to put this in the calculator, which we could do. Okay, so we could type e with an exponent of -2 minus 6 comes next. And then we would have to divide all of that, so I got to wrap it in parentheses. We're dividing that by 3. So this, because I have to cut off this decimal, let's say I had to cut it off to 3 places after the decimal, 955. Let's write that down. All right, this would be an approximate answer.